When we're working with systems like Windows and Mac OS, we've got a real fancy, shiny file explorer. And those fancy, shiny file explorers make it really easy for us to find files by name because they've got this really cool, like, search box where we can enter a file name and then find the files that we're looking for. But the problem that we've got right now is that we've been spending a lot of time working on the command line. And while sometimes we're working on our local system on the command line, and we could just open up Explorer or Finder and be able to find the files that we want that way, when we're interacting with a remote system, like when we're connecting to something with SSH, we can't really open up this file explorer and find a file using the file explorer. And so we're going to take a look at a command line tool that's called Find to be able to help us with that. Find is a tool that has a name that is pretty discoverable because it literally says what it does on the box. It finds files by name. Find by default, if I run find and then I type period, takes one argument. And the one argument that it takes is the directory that we want to find files in. So when I find files in the current directory, that's the dot, it's going to print out every file and directory that's in here. Here we can see that we've got a bunch of folders. So comp 1002 folder, the hello folder that has all the hello world examples that we looked at before, and a copy of the textbook, the Git repository for the textbook. When I run find with just a dot, it will print out every single file and folder that's in this directory, including the .git file that's in the hello folder. We're going to work with a different set of directories. We will also work with some of these other files and folders, but we're going to work with a different set of directories that will have a structure that kind of makes it prohibitive to try and use like searching through directories by just changing into them and listing their contents. So we're going to have to get a file, and we're going to have to get a file on the command line. So we're going to use that wget command. The file that we want to get is https://toolsandtechniques.ca/topic05/crazydirectories.tar. So crazydirectories.tar is a tar file. Tar file is a tape archive. And this is kind of like a zip file in that this is a file that has many files and folders inside of it. Specifically, a tar file is, again, a tape archive. And so this is meant to be a file that's used to write to tapes. And tapes are things like, we think about things like audio cassettes and VHS tapes, but there are tapes for the purpose of storing data. And that's the kind of tape that this is supposed to be writing to. For us, we really just care that this is a file that has more files in it. And we're going to interact with this using a tool called tar. Tar takes a couple of arguments. It takes the options that we want to give to it. So the first option that we want to give to it is X, and that means extract. So I'm going to say find tar dash. So this is a hyphen X. And then I also want to extract from a file. So I'm going to say dash F. And the file I'm going to give to it is crazy directories. So CR and then tab. If I press enter here and I type ls, what this has done is kind of like what unzip does. It's extracted the directory that was inside of this crazydirectories.tar file. So the X here means extract. The F is the file name that I want to extract. If I change into crazydirectories.tar, so cd, cr, and then tab, and I type ls here, what you can see is that there's a bunch of directories in here. And I'm going to change into one of these. I'm going to change it to U. And this has 10 more directories. So we got 26 directories and then 10 directories. I'm going to change it to one of these. I'm going to change it to 9. Now there's 26 more directories. So this is 26 to the power of 9 to the power of 26, or 26 times 9 times 26. So the arithmetic here is about, there's over 7,000 directories in this structure. I was able to extract this pretty quickly on my local system. But if you are working on a system that has a shared network drive for your user directory, it might take quite a long time to do this. This directory has way too many files and folders to be able to quickly find things in, and so we need to use a tool to help us with that. Find is able to find all the directories. So if I run find on dot here again and I press enter, it's going to print out everything, every single file and folder that it's able to find from here. But I want to find a specific file name. So I'm going to tell you that there's a file in here that has the name bananas.md. The way that we can ask find to help us find a file with a specific name is to pass it a new option or argument or flag called name. Name starts with a dash here, and then what name takes as a value is the name that you want to search for. So I want to search for a file that's called bananas.md. I'm going to press enter here, and very quickly, the only thing that it tells me that it was able to match that has that file name is this file bananas.md in this directory that is B5S. So I'm going to take a look at that. I'm going to use this cat command to print out what's inside this file. So cat b5s bananas.md. You found me. That's bananas. File names that we're searching for can also have patterns in them in the same way that the gitignore file was able to have patterns in it. So when we talked about gitignore, we were able to use things like an asterisk to say anything, any symbol, any number of symbols before this thing that I have, this pattern. And we were using that for things like I want to exclude files that start with a certain pattern, or more commonly files that end with a certain pattern. So there's 3 different characters that we're going to be able to use, or 3 different ways that we're going to be able to specify these patterns. The first one is the asterisk, like we've seen before. So I'm going to specify find in the current directory names, folders or files that have names that end with nanas.md. There's a couple of different files in this directory structure that end with that. So this pattern here says anything star that ends with this specific pattern. So nanas.md. We can also use a question mark. Question mark is something that we can use to find files by name with a pattern where we know one character is kind of a prefix or a suffix or somewhere in the middle of the thing that we're looking for. So I can say find from the current directory a name that matches the pattern question mark anas.md, and this is going to find bananas. So question mark here gets replaced just with one symbol. In that case, it's the B from the bananas file. We can use asterisks to kind of say like a file name that contains a specific string. So I can say find in the current directory the name of a file that has anything, and then banana, and then anything at the end of it. So this is going to search for something that has banana in its file name. I can also say that I want to find things that start with banana. So I'm going to press up on my keyboard to get this all back. So find from the current directory the name, a pattern that has banana at the end of it, or I can say banana at the beginning of it. So anything that starts with banana. The last thing that I can do is I can use something called a character class. So I'm going to say this one last time. Find from the current directory a file name that has a pattern, and then I'm going to say uppercase A, lowercase b, uppercase C, and then ananas.md. This pattern says I want you to find any file that starts with just the letters A, uppercase A, lowercase b, or uppercase C, and then ends with ananas.md. So this would match exactly 3 file names. Uppercase A, ananas.md, bananas.md, and uppercase C, cananas.md. There's only one of those files in this directory structure, so it only returns that one. We can use this character class structure to find files by name when we don't necessarily know the case. So one thing that we might want to try and find is if there's a file in here that has bananas, but it can be any of uppercase or lowercase a, b, or n, or s. We can do this by saying find a file name in the current directory that starts with a B, uppercase or lowercase, then has an A, uppercase or lowercase, then has an N, uppercase or lowercase, then has an A, uppercase or lowercase, then has an N, uppercase or lowercase, then has an A, uppercase or lowercase, then has an S, uppercase or lowercase, and then ends with .md. This indeed finds two different files, and here's a small aside. On a Linux system, these are two different file names. On a Windows or commonly on Mac OS systems, these are the same file name. So if you're running these same commands on Mac OS, you might not actually see multiple files here. If you're running this on Windows, if you have a find tool that you've installed for Windows, it might only return one file in this directory structure, but on a Linux system, by default, it will return both of these. That's insanely tedious, but this will match any possible option of uppercase and lowercase characters for that string. But it is insanely tedious, and so there's thankfully another option for find to help us with that. That option is iname. So I'm going to cancel this command. I'm going to press Control-C on my keyboard. What I'm going to say is find in the current directory iname bananas.md. So iname here says ignore case. It doesn't matter which case it is as long as it matches the ASCII characters that I've got for that. You can use any of the characters that we were using with patterns for this. So I can say iname anything that ends with .md. I can say anything that has banana in it, like this. So asterisks on either side, and it will still find both of those patterns because it's ignoring the case of the files that we've got. The next thing that I want to do is that find actually gives us the ability to run commands, and it gives us the ability to delete files that it's found for us that match the patterns that we've asked it to find. So the first thing that I want to try doing is deleting a file with find. So the first thing I'm going to do is I'm going to say find, and I want to find a specific file by name. I want to find ananas.md. And this is in a different directory than the other bananas file is. When we have found the name of the file that we want, we've confirmed that find is only returning the list of the files that we want. We can pass it the delete option. A lot like RM, there's no trash can here. There is no trash can, and so when we do this, it's going to delete that file. It's not going to be recoverable in a very easy or straightforward way if it is at all possible to recover it. My strong advice to you would be to make sure that you run find without the delete option before you run it with the delete option to make sure that it's only going to delete the files that you're expecting it to delete. So if I delete this file now, it doesn't return any output to me, but if I run this command again, it's gone. I've deleted it with the find option. This is kind of useful sometimes to delete files with find if you know that there's a certain pattern. So for example, if you're working with Java and you've compiled a lot of Java files into class files, you may want to delete all of the class files that are in a directory. And so you can find in the current directory all files that end with .class, and then you can delete them. That will delete all of the compiled class files from a Java program. Deleting is fine, but really commonly what we want to do is to run programs on the files that we found. Find has another option for that, and that is to have an option that's called exec. So I want to find in the current directory all files that end with .md, so all files that are markdown files. I'm going to type the next part of this in, and then I'm going to step through it. So I want to find all files in the current directory that end with the name .md, and I want to execute a command on that. So -exec. The command that I want to execute is pandoc, because I love pandoc. I want to pass it a file name. I want to convert it from markdown and emoji, and I want to convert it to a docx file. And then that's the end of the command that I have. So let's step through this command. It consists of a couple of different parts. First, this part here is the find command. So in the current directory, I would like to find all files that have a name matching this pattern. So all of the files that have anything but end with .md. And on each of those, I'd like to run a program. After that, the rest of this now is going to be the way that we run a program. So when we run pandoc on the command line, we run pandoc, we pass it the name of a file. In this case, what find is going to do is for each of these file names that we have here that it's returned, it's going to replace this one at a time with those file names. So we're saying run pandoc on this file first. I want to convert it from, and this is a pandoc option. So notice that the options between these two different programs have the same kind of pattern. They both start with these dash symbols, and they have a string after that. I want to convert it from a format that is markdown and emoji. So I want to have some extra support for emoji. I want to support these emoji shortcodes here. And I want to write out to a file that has that file name, so robot.md with a suffix of .docx. So I want to convert these to Word files. This last part here says to find, this is the end of the command that I want you to run. So everything that's in between exec and then this \semicolon is what find is going to run for us. So if I press enter here, it's going to go through all of those files and it's going to do effectively pandoc. It's going to paste in the name of this file. So r3t robot.md from markdown plus emoji -o and then r3t robot.md.docx. And it's going to run that for each of those file names. If I run find and from the current directory name that ends with docx now, what we're going to see is that there's these 3 Word files that I've created by running find and exec. Find is a great tool. It's excellent, and it kind of breaks one of the things that we think about with Unix and Linux command line tools, which is you do one thing and do that one thing well. Find kind of starts to do other stuff, like involving itself in deleting files and giving you options to run other programs. You will explore this a little bit more in later courses in computer science. So in Comp 3430 or an operating systems course, you're going to explore the idea of how find, which itself is a program, is able to run other programs. But for now, all we really need to be able to do is to find files by name, either by a specific name or using a pattern, and then be able to delete or run programs on those files.